Hello, Math 140 students. I'm your instructor, Cindy Enrique, and today we'll be going over section 1.2, which will talk about fractions. So this is the only section in chapter 1 that we are going to cover. So it's all about the fractions. Hopefully you guys have some familiar concept of fractions. If not, don't worry, we are going to review them together. So a fraction is a number of the form a over b, where a and b are integers and b is not a zero. So of course you've seen fractions like maybe like 3/2 as a fraction, right? The denominator of a fraction, so the thing on the bottom, that's the denominator. And that shows the equal parts in the whole, and the numerator shows how many parts are being considered. So up on top you always have the numerator. So we have the denominator and we have the numerator. And that can tell you a lot about our fraction. If the numerator of a fraction is smaller than the denominator, the fraction is a proper fraction. So here it's about vocabulary. So a proper fraction is going to be less than 1. So here we can have, let's say, 2 over 7, because that is going to be less than 1. If you look at the decimal approximation, so if you bring up a calculator, which we are allowed in this class, if I have 2 divided by 7, 2/7, you get the decimal approximation of 0.2857, and that is definitely going to be less than 1. So decimal is less than 1. Okay, so therefore it's going to be a proper fraction. Now, well, what if it's not a proper fraction? Well, if it's not proper, then it's going to be an improper fraction. And that is going to be a fraction that's going to be greater than or equal to 1. So let's say we change this up. What if we had 7 over 3? Well, we know that this is going to be an improper fraction because the decimal is, well, let's confirm it. Let's bring up our calculator. If we have our 7 divided by 3, so 7 is our numerator, 3 is our denominator, and we want to know whether or not the decimal is going to be greater than or equal to 1. If it's improper, this decimal has to be greater than 1. Well, we see that it's 2.333. So therefore, we know that that's bigger than 1. Is equal or greater than 1. Okay. And the last thing we want to know, or sorry, not the last thing, but the next thing will be division by 0. So what happens when you divide by 0? So for example, if I had 5 divided by 0, well, what does that mean to have a 0 in the denominator? Well, let's see what happens when we put it in our calculator. If we have 5 divided by 0, it says error. You can't divide by 0. So what does that tell us? Well, it tells us that you can't ever have a fraction with a denominator of 0. It doesn't exist. The calculator and the world, all the scientists, we don't know what happens. It's going to be undefined. So here your 0 is your whole. How can you have 5 parts when you have 0 wholes? That doesn't make any sense. But in mathematical terms, we say that it's going to be undefined. Now, we also have equivalent fractions. So if we have equivalent fractions, it just means we either made the fraction bigger or smaller. We make it bigger by multiplying. We make it smaller by division. But it's all going to be the same numerical value. So here it says, if a is a real number except in 0, then a divided by a is equal to 1. In other words, when a non-zero number is defined by itself, the result is 1. So this is telling us that if we have, let's say, 3 over itself, then we're always going to have equal to 1. And it works with every number. Even if I did, let's say, 257. Well, if I divide it by 257, I know it's always going to equal to 1. And also, whenever we divide any number by 1, the result is that actual number. So for example, if I were to have, I don't know, some number, 7 over 1, that's the same as 7. Or if I have 138 divided by 1, it'll equal to 138. Now we're going to have some examples. Find the missing number that makes the fractions equivalent. So here I have for number 1, 7/12, and I want it to equal with the denominator of 48. So the only thing that we have to compare are the denominators. So if we are making the denominators bigger, right, we went from 12 to 48, we're definitely making the denominator bigger. So that tells us that we are going to be multiplying. So what number do you multiply top and bottom, 7 and 12 by to get to my denominator 48? Well, you can do this on your calculator. To figure out the number, well, you want to know 12 times what is equal to 48? Well, if you actually went the opposite, 48 divided by 12, that's going to be 4. So that tells us that 12 times 4 is going to equal to my 48. So what I did is I times that by 4 to get to my 48. Now I'm going to have to do the same thing to my numerator. Whatever I do to the denominator, I also have to include in the numerator. So now that numerator is 7, and I'm going to times that by 4, and I'm going to get my 28. So I know that this is going to equal 28 because I multiplied 7 times 4 equal to 28. So that is how I'm going to get my equivalent fractions. So for number 2, we have negative 54 over 72 is equal to a negative 3 over, and now our denominator is missing. So since the denominators are missing, that means that we can compare our numerators. So here from 54 to 3, how did that happen? Well, the numerator got smaller. So since the numerator got smaller, you're going to be thinking about dividing. So 54 is going to be divided by some number equal to 3. Let's go ahead and write that out. And so when we do this in the calculator, if we have a 54 divided by 3, we get 18. So now I know that 54 divided by 18 is equal to 3. So since we figured out the missing factor, let's just make sure 54 divided by 18 is equal to 3. So if that's the case, you're going to have to do the same thing with the denominator, which is going to be divide by 18. So you're dividing by 18 in the numerator and the denominator. So if I have 72 divided by 18, I'm going to get a positive 4. So my answer here will be a negative 3/4 is going to be the equivalent of a negative 54 over 72. So we're going to go ahead and do this and simplify to the lowest terms. And again, you guys are allowed your calculator, so yes, you can divide by 2 or 4 or whatever the common factor is, or you can use your calculator directly. You guys are allowed to use calculators in this class. So if let's say you're using a TI-84 plus CE, if you want to put a fraction into this, you're going to press that green button that says alpha. So maybe you can see the cursor here, so alpha. And then you're going to go up to the very top where it says y equals. And now, since I see that fraction, n over d, that means numerator over my denominator, I press enter. That's how I get my fraction. So in my numerator, I'm going to have 156. I'm going to scroll down, and that's going to be 210. So 156 over 210. And it's going to give me the reduced fraction. That reduced fraction is going to be 26 over 35. And so that will be my answer for number 1. For number 2, same process. So I'm going to go ahead and go to alpha, y equals, enter. My numerator is 312. And my denominator is 378. And so that gives me 52 over 63. And to reduce this fraction, you can also think of it as it has, 160 and 1,000. And you know here that each of those are going to be divided by an even number, and it's definitely going to be higher than 10 since they both end in a 0. But let's see what it's going to be. So I have 160 in my numerator and 1,000 in my denominator. That's going to be 4 over 25. So that would be my final answer. And that is how we simplify to lowest terms. Now, example number 3 is slightly different. What we want to do here is do the prime factorization. So here we are really looking at the prime factorization. So if I'm looking at the number 64, then I can think about 2 factors that multiply together to give me 64. So what 2 numbers multiply together to give me 64? Well, the fact that it ends in a 4 tells me it's going to be an even number. So I can divide by either 2 or 4. So 64 divided by, and let's just do 4. I have 16. So that means 4 times 16 gave me that 64. So perfect, 4 times 16. From here, what you want to do is you want to keep breaking it down. So here, the 4 is 2 times 2. And 16 would be 4 times 2. But you already know that this 4 can be broken down even further to 2 times 2. So now you have all of these factors that represent the prime factorization of 64. So let's see how many 2's I have. So I know I see a bunch of 2's, and let's count. 1, 2, 3, 4, 5. So I have 64 is equal to 2 to the 5th power. Now let's go ahead and look at the number 810. Well, I already know, since it ends in a 0, that this can be 81 times 10. And I know that 81 can be broken down. I'm just going to choose a different color here. 81 can be broken down as 9 times 9. And 10 can be broken down as 2 times 5. Now, if I look at 9, well, that's 3 times 3. And this 9 is also 3 times 3. And that's as far as I can factor these numbers. So now I know that I have 810 and its prime factorization. Well, if I just go from smallest number to biggest number, I have 1, 2. That's it. And I have a bunch of 3's. Let's count how many 3's that I have. Well, I have 1, 2, 3, 4. 3 to the 4th power. And I also have a 5. So now I know that 810, the prime factorization is 2 times 3 to the 4th times 5. And that is the end of this section. If you guys have any questions, please feel free to contact me or the Math Success Center or the tutor. Thank you.